Hello 9 starter. So today we'll be looking into the second set of numericals of 2a. Okay, so this is on your 2a concept. So far in your last video we saw the numericals on speed, velocity, the conversion from one unit system to the other unit system. So in this we'll be looking into the numericals of acceleration. So before going into the numericals, I just thought to have a recap on your definition of your acceleration. So acceleration means change in velocity by time taken. So change in velocity, which means your velocity is changing either from a smaller value to a greater value or from a greater value to a smaller value. So in acceleration also we noted it has two way, one is positive and another one is negative. Negative acceleration is called as your retardation. So now listen, your acceleration is nothing but change in velocity by time taken, for which I'll write v minus u by t. So a stands for acceleration, v stands for final velocity, u stands for initial velocity, and t stands for the total time in which all these are happening. So v means final, u means initial. So this I have to identify properly in a given numerical. So consider this example. A car is starting. So whenever a car starts, initially it will be at a zero speed. It is not going to have any velocity. So when a car is starting, initially its velocity will be 0. And after starting, I'm going to drive at a speed of 40 km per hour. Therefore, this is my final velocity. So you can also note it down the starting point of a car, or it can be also told as the rest position of your car. The car which is at rest is starting and it is moving at the velocity of 40 km in a time of 2 hours. Find the acceleration. So that is how the question will go. So we'll be blinking what is your initial velocity, which is my final velocity, because velocities will be given in an indirect manner also. So whenever a car starts from a rest, so in that case your initial velocity is 0. So this is in a case of your car. Next one, I'm just going to drop a stone vertically down. Okay, dropping a stone vertically down. I'm just going to drop something like this. So when you drop something, you're not going to apply any velocity. You will never apply any velocity. Only if you want to throw, you will apply. You want to drop something, you will never apply anything. So if you want to drop something, here my initial velocity is 0. And the stone will reach the ground with some velocity, some final velocity. Let me take it as again 30. Okay, 30 meter s minus 1. So it will drop in this velocity and the time for 2 seconds or 3 seconds, that will happen. So in this case you have to understand initial velocity is 0, but it will have a final velocity. Now the other example, I'm going to throw in a upwards direction. So I'm going to throw, a stone is here, I'm just going to throw in a upward direction. So once when you throw, you will have to apply a velocity or throwing up. So we just try to do it, take a pen, throw up. You feel you will apply some velocity to it. So in this case your u has a value somewhere around 20 s minus 1. So when this velocity becomes 0, automatically the stone which you're throwing up will come and fall down. So when you throw up, okay, whenever you throw an object vertically up, it will have a velocity, and the top and the maximum height, the velocity will become 0. So you will have an initial velocity and the final velocity will become 0. But whenever you drop a stone down, in that case your initial velocity is 0, but it will have a final velocity. And in your car there is also one more category, I just forgot to say. So in your car, now listen, the car is moving with a velocity of 50 km. You're going to have a sudden brake. So what will happen after the brake? The car will eventually stop. So this is your u. So now my u will become 50 km per hour, and after the brake my car will stop, by which my final velocity has becoming 0. So these are the two cases which you have to note down before doing your sum. So based on this, we will understand whether it is a positive acceleration or it is a retardation. Now look at your ninth sum. So it states that a body starts from a rest and it acquires a velocity of 10 meter per second, and all these are happening in a time scale of 2 seconds. So since it mentions the body is from rest, okay, it is starting from rest, and I told you whenever the body is in rest, its initial velocity is 0, and it states it has acquired a velocity of 10 meter per second. So therefore your final velocity is 10 meter per second, and in a time is 2 seconds. Now use your formula. A is equal to v minus u divided by t. We know v is 10 and u is 0 by 2. Therefore 10 by 2, that is pi. Now what is my acceleration? 5 meter s minus 2. Note down the unit. Whenever you solve a sum and in the final answer, if that particular physical quantity has a unit, you have to mention the unit. Okay, so meter s minus 1, it clearly means it is your velocity. If it is s, it means it is your time, and meter s minus 2, it means it is your acceleration. Okay, now come back for the 11th sum. In your 11th sum, it states a body is thrown with a vertical thrown up vertically with a velocity of 50 meter per second, and after some time it attains a velocity of 20 meter per second, and at that time the time was 3 seconds. So using this, calculate the acceleration. I am supposed to calculate what kind of acceleration it is. Okay, I'm throwing an object with the initial velocity of 50 meter per second, and after 3 seconds the velocity changes into 20 meter per second. So whenever the velocity changes in a time, we call it to be as your acceleration. Therefore A is equal to v minus u by t. Now what is my v here? What is my final velocity? 20. And what is my initial velocity with which I'm just throwing the object? That is 50. And all these are happening in a time of 3 seconds. Therefore 20 minus 50 by 3. So minus 30 by 3, which is 10 minus 10 m s minus 2. So whenever it is minus, it indicates it is a retardation. It is negative of acceleration, therefore it is your retardation. Okay, clear? It is negative acceleration, therefore it is called as your retardation. So now for your 12th sum. The 12th sum states that an object is moving, a toy car is initially moving with a velocity of 15 km per hour, and then it stops. So initially it is having one velocity and its final velocity is becoming as 0. And all these are happening in a time of 2 seconds. Okay, the time taken is 2 seconds. So I have to find my acceleration. So what is your acceleration formula again? V minus u by t. So v is 0 minus 5 divided by 2. So minus 5 by 2, which is minus 2.5 ms minus 2. So all these are simple sums. Only you have to know which is your initial velocity, which is your final velocity. So if you understand this, you can solve the remaining sums which I have left for you to solve. Okay, this is from your numericals. You can practice the sums from your examples as well as your numericals.